Time for another day of Advent of Code. This is my 14th. This is the 14th day, and I have 26 stars so far. So today I'll be aiming for stars 27 and 28. Let's go ahead and get things set up because I have only a couple of minutes. So let's create my day 14 input file, and let's get a fresh Go toolchain. And then we'll be ready to do the puzzle in about 3 minutes. Hope everyone had a wonderful day. And I hope this is not necessarily a new room. It's different than last year for sure, though. Last year there definitely was a temporary apartment. So if you're noticing something a little different, I think it might be the color range of my camera. I accidentally touched one of the settings, and now it's showing me super yellow rather than super blue. It happens. So anyways, where were we? I was going to talk about... What was I going to talk about? I don't remember what I was going to talk about. Let's go ahead and make sure I have all of these stuff that I will need in order to deal with potentially tracing, if this problem today involves tracing. If it doesn't, that's fine too. So delete all the data structures I created for day 12. And that should just about do it. Okay, something like this should do the trick. In case it involves numbers, I'll put strconf back on the list. Okay, and I can take sync off of the list. That looks about right. Excellent. Oh, and today, at least for populating honeycomb traces, today is not day number 12. Let's go, Viwu, let's do it. Good luck to you. Okay, let us see. Let's see what we can do here. Oh, it is still building my toolchain, but that is fine. It'll finish. It'll finish before the puzzle unlocks. And even if it doesn't, I usually don't need my compiler for a little while. Hi, Eric. Thank you. I appreciate the wishes of good luck. It is a weeknight puzzle. I'm not super scared, but, like, you know, we'll see. I have been spending more and more time optimizing code recently because of Advent of Code. Advent of Code has made me think about algorithms a little bit more than I normally do. For instance, I spent the past couple of days figuring out how to deal with sorting a list where the entries are integers that are in sequence, and except for they've been mixed up by the file system, and yeah. So that's been fun to learn that I can probably just bucket sort first before I break the problem down into subproblems that I run quicksort on, instead of trying to naively quicksort the whole thing, which results in things taking substantially longer. So memory CPU trade-offs, good times, good times. The other advantage of that is being able to parallelize the sort, which you otherwise wouldn't be able to do. Right, here we go. All right. Oh, okay, this is a polymer puzzle. Yes. Yep. Simultaneously considers all three pairs. Oh, just the adjacent ones. Okay. All pairs are considered simultaneously. Inserted elements are not considered to be part of a pair until the next step. Okay. So what do you take if the quality? What's the quality metric? Oh, quantity. Okay. Wonderful. I know how to do this. This feels pretty straightforward. Okay. So this one is also, I think, going to be a fun one to visualize, so we'll do some honeycomb visualization of this afterwards, if time allows. Okay, So, so this thing here is just going to be a string, which is just going to be split 0. Okay, and then from lines 2 onwards, we have a bunch of rules. Parts is going to be strings split s with that operator. Okay, and we need to define something to define a rule. So the rule is going to be a left-right rune, and it returns another rune. In fact, left-right. Okay, that'll make that clear. All right, so parts 0, 0. Okay, so we're going to do something like this. Parts 0, 1, and then insert parts 1, 0. Okay, that should do it. Let's just check that. So we have a polymer, we have rules, something like that. Okay, now let's just print this to make sure I got this right. And print line, rules. Okay. Let's see what happens here.
Yeah, exactly. Such bullshit.
Why is this? Oh, okay, I was just thinking about it. Line 20. Oh. Type rule struct, because I cannot remember how to go today. Okay, that looks better. And this, oh, that needs a close paren. And I don't need circon because I'm not working with integers today.
Sure didn't.
And I don't need attribute yet. Okay, so this should yield something useful. So I've got my initial string that matches, and I've got a sequence of rules. And the last one should be, let me just check this.
It actually does have range over all of Outer Rim, like every single system. And it also hits XM and 0T if you need to get back.
How do I do this? I need to convert the character H. You know what? I trust this is fine. I trust that I successfully did this. Because if I did this correctly, HCF. Yeah, CDEF. Yeah, that looks correct. Okay, good. Okay, so now that I've checked this, let's go ahead and run this. I'm supposed to run 10 steps. Okay, so let's run the 10 steps and see what happens. Okay, and let's also define like so.
The wrong way of thinking about it is a
okay, so we'll define it like this, and then that way I can just actually no, I don't need to bother doing this. Actually, this is fine. I'll make the method on rules. Okay, so now that I have something like this working, let's define a.
It's way easier than trying to tank with this tank you do while y'all burn into range?
Okay, so that's going to take a string and return a string. And then afterwards, in range Polymer,
check out the,
I'm squinting because I'm looking down at the bottom when I shouldn't be. Okay, so now frequencies, it's going to be a map from rune to int. Frequencies C plus, and then for k be in range frequencies.
Pretty looking people. I like always
so most is going to be 0, least is going to be length of Polymer.
I combated him and landed in Yurkin, and I knew he was like close within a few kilometers of me,
So
and I
now,
just tagged him, and he
if v, actually I don't need this, I don't need the key. If v is less than least, then least equals v. If v is greater than most, then most is v. And let's go ahead and print our output. Most minus least.
I've never seen that.
Okay, so now I just need to write my grow function. So the grow function will
It's not like totally unbelievable because the missiles do get simulated, right?
Okay.
You can firewall them, but I just like
okay.
I've never
So
seen it happen.
for it makes sense to me
I have no idea that.
to
I don't know.
repeatedly evaluate each rule along the string.
You could try it on CC. There's like parquet shift between a missile ship and a target, and then wait.
Although, yeah,
Yeah.
actually, no. Let's have. I think this works out about the same. Pause is 0. Pause is less than length of input minus 1 because we need to consider the pairs. Okay. So now we're going to have so output is a string builder.
Do you want to do it?
So the string builder class so I have a
Wait, where is this?
builder. Okay, do not copy a non-zero builder. That's fine. I know not to do that. Okay. So, first of all, output dot write rune, I think. Is there a write rune? Yes, there is. Excellent. So first we're going to write rune of input pause.
Yeah, put your drones out.
Actually, this is going to be write byte, but it doesn't really matter because these are not UTF-8 strings, so it's okay.
Impending incredible feat.
So now, if rule left is not equal to
Nothing bad has ever happened dropping on a truck.
rule left is input pause. So in fact, these are not going to be runes. These do need to actually be bytes. That's fine. Okay. Yeah. Okay. That's fine. We'll do it this way. Despite my fascination with runes, we don't actually need that. Okay. That's good. input will insert. Finally, length of input -1.
Not
okay,
sus.
so I think that should do the trick. Let's see what it does. This is R.
Plan is we all.
Okay, so this
We all
needs
sign
to
away
be
to
a
doc.
rules. And finally,
Go for it.
line 68. Oh,
Make a
that's
conduit.
just going to be a make.
Here we go.
Line 70. Okay, so this can still say room. That's okay. Okay, I got an output. Let's see whether it's correct.
Back up, tackle.
That's correct. On to part 2. We'll need to run a total of 40 steps. All right. This might get a little gnarly, but I guess we'll find out what's about to
practice is
happen.
very helpful.
So let's go ahead and encapsulate this in a function.
Theory, please. Might be one of us. People are already looking up. I'm gonna dock up
Okay.
the cap back. Cap is using free.
So the naive approach probably doesn't work, but we'll find out.
Alright, well, it wasn't bait.
Okay, return most minus least.
Grab praxis that have cloak.
It probably would be wise to print out what iteration I'm on and what the length of the string is, just to...
I'm bouncing to the station you guys are on. I'm through the phone. Yeah, I need to dock and undock for cap.
Okay.
With just lots of battleships.
Okay, so it's roughly doubling in size with each iteration. So basically the core problem we're going to have here is that doubling another 20 times is going to yield a very large number. Yep, so we know that this is not going to work. Okay. So let's see
Dock and undock
whether
and
there
down,
are any
down,
common substrings that we can use in order
Our
to
red should be down now.
agglomerate this.
God.
So I'm just going to really quickly check a theory.
Oh, conduit off the.
A theory that I
Back to
have
the
is maybe the frequencies list is something that is...
It's the inside a gated site.
Okay, so let's do this.
Pile of lost battleships on the undock.
Okay.
Suspect, but not sus. Oh, good decloak, right?
All right. So let's try this theory just to see whether any obvious patterns jump out at me.
All the colors on my ship are kind of faded, I guess.
Is this exactly doubling? No, it's not exactly doubling because some of the time it more than doubles, and some of the time it does not more than double. Okay, so let's check this. So
that's the new
last
game has done.
frequency going to be 1.
He's like, yo.
So
yeah, and you can't slide them. You
last
can only slide them with
frequency.
industrials too. Yeah, you have to slide with battle ventures if you want to kill people. Or battle skips. Yeah, that's why they don't warp out, they know you can't slide.
Alright.
Actually, or
Frequency.
bridging around battle procs.
So I have a suspicion about this. So it's not quite exactly doubling. What is this pattern? What is this pattern? Have I seen this before? Interesting. Okay. So the things that are jumping out to me are... I understand what I have to do. I understand what I have to do. I need to keep track of the number of adjacencies in a map. So that's what I'm going to do. I don't need the actual polymer. What I need is to... I'm going to do this. Okay.
Yeah, big feed. I think I've seen a video of that.
Trouble is, I need to keep track of what's on the far left-hand side and the far right-hand side, but that's always going to be the first character.
Now I need to go find this video. I've seen
Aside from those, I'll essentially have duplicated... Okay, I understand. Yep. Okay, so left, right, byte, and then... okay, I know what I have to do here. Okay, so now a polymer consists of a inner elements
I found it.
and then I'm going to have a left and a right.
Oh wait, this is a different fleet.
Okay. So now I understand how to do this. So instead of doing it this way, we can just delete this entirely.
They are gated. I don't know if you can light on the outside, but I doubt it.
Okay. So
Unfortunately,
Let me
he's
do
also
it
probably
this
pretty
way.
long for warping, so. I believe
in
they are
fact,
all
I can also encode this to be faster this way.
I'm pretty sure they are all
Type rule is going to be just a map from polymer pair to byte. Okay. So that looks Okay.
If he slides the gate, he can't sign him inside. If he doesn't slide the gate, he has no tackle.
So
this White Storm muster point, there's a demo sitting in. It's on narrow.
all right. So how do we do this? Pair R index pair So for each pair,
Alright, I think we should probably head back home.
Make
someone have an XM covered handy?
Polymer.
Okay. Yeah, let me know when it's lit. I'm gonna convo this one.
Alright.
I don't know if
So what I'm doing here is I am keeping track only of the number of pairs. So I'm decomposing the string into pairs, and I'm just keeping track of what's on the left and right hand side because I know that I can't double count that.
I could take a to LT, but then do a big then go to XM.
All right. So let's see this.
Yeah,
so
if you don't want
then
to 0LT combo, you should redock.
Insertion next index. I'm instead of calling it polymer pair, I'm just going to call it pair. Okay. So great, this will work. So next pair.
It's so good. All right, can we get the covered up in
I'm
gonna send it.
Oh.
Here we go.
Plus equals the count.
Nice. We're home.
Insertion, comma, pair dot right.
Yeah, you did catch whoever got the practice.
Okay.
The 60 cloak. It's true, there's too many of them.
Map pair int.
Sure.
Okay, and finally we return a polymer with inner elms, pairs, and outer input outer. Okay. So that should do the trick. So now, this rule gets replaced with a map from pair to byte. So rules pair left and right goes to this. Okay, that seems to do the trick.
Lopsing around is really
now over here, we take as an input the polymer instead, so we need to construct the polymer. So, the raw polymer so basically I take no, I can't use that, so okay, for I is 0, I is less than length of polymer raw minus 1, I plus plus, and then for polymer polymer. Actually, okay, so we have something like this. 30 minutes already? Yeah, I should have spotted the trick coming and ridden it this way to begin with, but that's okay. Okay, so the outer is going to be a make map error int, and then the outer is going to be polymer raw 0, polymer raw length of polymer, raw -1. Okay, looks good. So now so now this code just needs to be updated. Don't need to get the frequencies, I just need to run the grow, that's okay. So over here, this takes a polymer over here. Okay, so the map from byte to that. Polymer.innerElems. Okay. And finally, we'll do that, and then we can go through and let's just do int 64 and int max. I'll just import maths. Yes, it does double count, but the trick is I'm going to divide the answers by 2. So I needed to make sure that I kept track of left and right so I could double count exactly the correct number. Because the leftmost and the rightmost don't get double counted, so that's why I did it that way. Okay. Polymer.left. Where did I leave that? Oh, polymer dot outer left, polymer outer right. Yep. Okay. Cool. So now I just need the grow function. Actually, the grow function is done. Probably it's going to complain at me a bunch. Line 20, what did I do wrong? Oh, that's just a struct. Line 23, again, struct, that always bites me. Okay. Oh, it's called max int. Okay, there's my answer, so we'll just plug that in and see whether I'm correct. Oh yeah, that's correct. Top 1,000. Nice. Okay, that ran nice and fast. So let's actually demonstrate that it is basically constant time per round, and therefore it's just linear in the number of rounds. yeah, it is much faster to just keep track of the pairs because they all do the same exact thing. Awesome, cool. Well, cool. I've got 28 stars now. So now let's go check out my employer, which is the sponsor, Honeycomb. And, oh, wow. Ramp just, like, displaced Ahrefs by throwing in, like, probably, like, $15,000. It's now on the top. That's amazing. Okay. I love the ranked aspect of sponsorship of Advent of Code. Anyways, we're here. We are Honeycomb. We do distributed tracing. And what I'm going to do today is now let's go ahead and annotate this. So, we're going to wrap a span around parsing. And then we'll do we'll show the parts. So we'll do something like this, and then defer my span end. Now let's go ahead and show the parsing. So okay, and once we've finished the parsing, we're going to end the span. And let's throw in some attributes as well. So for instance, I'll throw in an attribute indicating the let's see. I'm just going to quickly crib some notes because cribbing notes is always a helpful thing to do. So, I can just take my source code here, set attributes. Okay, attribute int. Put length. And let's also give it the attribute of rule length. Okay. So having done that, let's go ahead and pass in the context. And we'll go ahead and do this. So we'll pass in the context as well. Actually, no, let's do it this way. Let's just pass through the context all the way. All right. Cool. So something like this. Right, so that should just about do it.
Still have my block sender wandering around.
Oh, and now it's complaining to me saying, hey, I can't authenticate to Honeycomb, which is fine. We'll just go ahead and set an API key. So I'm going to come over here, go to my team settings, really quick off screen. I'll just go ahead and grab my API key real fast. So I have a write-only API key. Now I can show you my desktop. Okay. Cool. So now I should have a nice, lovely trace, which has 52 spans. So yeah, we can see that we spent about 120 milliseconds of, I can drop the service name. We can see that I spent about 120 milliseconds of parsing, and then after that, like, the time to grow is remarkably consistent. It takes not very long at all. So that's how you have it not explode, as opposed to the previous solution, which basically was growing in the size of the input and was taking longer and longer. You saw it on stream. It was taking, like, tens of seconds per generation, whereas each generation stays in the microsecond range, which is pretty nice. So that is your daily dose of Honeycomb since you were watching my stream. And if you thought that was cool, if you want to apply that to your own projects, go check out us on the sponsor page. And with that, about 1,400 people have finished the puzzle. I'm one of them, and let's go ahead and share the love with someone else and raid another channel. Thanks for joining me, folks. Let's go ahead and say hi to Viwu.